Okay, so first one, 4 plus 16 cube root x to the power 4 over 8 root x. So rewrite it all, and I'm going to split it up. So 4 over 8x to the half plus 16 x to the power, so 4 over 3 over 8x to the half. 4 over 8 gives me a half, x minus a half. 16 over 8 gives me 2, x, take away the powers. So I'm going to do a mistake if I do that in my head. So 4/3, take away a half, gives me 5 over 6. First one done. Okay, next one. So we got y equals 5x plus 1 squared times ln 2x plus 3. And we want to get the exact gradient when x equals 1. So that means we need to differentiate. And to differentiate, we're going to use product rules as a secret times there. So uv dash plus u dash, where u equals 5x plus 1 squared. V is ln 2x plus 3. So u dash is differentiated, so 2 5x plus 1 times by derivative of the brackets times by 5. So that's 10 lots of 5x plus 1. And v dash is 1 over 2x plus 3 times by the derivatives times by 2 gives me 2 over 2x plus 3. Sub into the formula. So dy by dx is u times that. So 2 lots of 5x plus 1 squared over 2x plus 3 plus v times u dash. So 10, 5x add 1, ln 2x add 3. And we want to work out the gradient when x equals 1. So then x equals 1. So dy by dx, so into there gives me 6. Squared is 36. Times 2 is 72. Over 2 add 3 is 5. Plus 10 times 6 is 60. ln 2 add 3 is 5. So 60 ln 5. I'm going to leave it like that, not type in my calculator, because the one's exact. Third one, use the trapezium rule with 4 strips to estimate the area from 1 to 3 of x to the power x dx. So we need the table, x, y. So there's 4 strips, so 3 minus 1 over 4, that's 0.5. So h is 0.5. Let's start at 1 and go up to 0.5s. And it says use 3 decimal places now working out, so I'm going to go onto the table mode. I'm going to type in x to the power x. I'm going to start at 1, end at 3, go up to 0.5. I'm going to get my values. So 1 and 3 decimal places, so 1.837, 4, 9.882, and 27. Then I'm going to use the trapezium rule, which is half h y0 plus yn plus 2 times the rest, so y1 up to yn minus 1. So half times 0.5 times 1 at 27, 2 lots of the rest. I'm going to type that into the calculator. So 0.5 times 0.5 times 28, 2 lots of 1.837, 4 at 9.882, close both brackets, we get 14.8595, and it wants 2 decimal places, so 14.86. And everybody can check on the calculator by working out the actual number, or better estimate rather, x to the power x from 1 to 3. 13.725, so we're close, so suggest that answer is likely to be right. Okay, next one. X plus 1 to the power 4, take away 8 lots of x plus 1 squared plus 15 equals 0. Now this one, you might be tempted to expand and get a quartic, but then we can't really solve quartics easily. So instead, think about it. There's 3 terms, and what type of equations do we normally get in L maths? We normally get quadratics. Well, this one's got the smaller power, so this one looks like it should be the y term, x plus 1 squared. And if I square that, I double the power, so y squared is x plus 1 to the 4. There we go, it's just a quadratic. Y squared equal 8y plus 15 is 0. To solve it by factorizing it or being lazy by typing in your calculator. So 1 minus 8, 15. We get 2 answers. We get y is 5, y is 3. Sub back in what y was. X plus 1 squared is 5, or x plus 1 squared is 3. Square root, both sides. So x plus 1 is plus or minus root 5. Take away the 1, so minus 1 plus or minus root 5. The same method there, 2 minus 1 plus or minus root 3. So there's your 4 answers. See, much quicker than having to expand that. And last one, rearrange 2 lots of ex plus e5 equals 7y. Okay, first of all, e5 is just a number. Okay, so just treat that as a number. So I want to get x by itself. The first thing we can get rid of is this 2. So I'm going to divide both sides by 2. 7y 2. Then I'm trying to get x by itself. So let's get ex by itself. So I'm going to take away e5 from both sides. So 7y over 2, take away e5. Then I want to get rid of the e. So I'm going to do ln on both sides with brackets. So the e and the ln cancel out. So I get x equals ln 7y over 2, take away e to the power 5. And that's it.